My name is Hans Venema. I'm the CEO since 2014, but I started my career in the energy sector when I was a boy of 15, 16 years old as a meter reader in the northern part of the Netherlands for a small local gas distribution company. I liked it a lot, and so there I am, now responsible as CEO for Gasunie. And it's an honor and a pleasure. Gasunie is a state-owned company that owns and operates gas infrastructure in the Netherlands and in Germany. And we also have some interconnectors towards Russia or towards the United Kingdom. The role of natural gas in the Dutch gas system is very important. We have here the big Groningen gas field, so our society is basically based upon natural gas. So on the medium term, from now till 2030, I think natural gas will still be rather important. Afterwards, the importance will decline, and I think more and more natural gas will be replaced by what I call green molecules. So that could be hydrogen, or that could be green gas, etc. So there will be a shift from natural gas to green molecules. Together with TenneT, and TenneT is the electricity TSO, so the high voltage grid operator in the Netherlands and also in Germany, we worked on the concept of the North Sea Wind Power Hub. And the concept is building an island on the North Sea and connecting this island with lots of wind farms and having all the installation from the island. So you store there the equipment, you'll have there the people residing in hotels. You connect many wind farms there. Then you connect this island electrically with the United Kingdom, with the Netherlands, with Germany, with Denmark and with Norway, and you balance the electricity grids in those countries. But we see that if we connect a lot of wind farms, that there is too much electricity when the wind is blowing very hard. So therefore we also put some power to gas installations on the island. And what these power to gas installations do, or power to hydrogen installations, they convert electricity into hydrogen. And we can use this hydrogen, we transport it to the shore, we can store it there, so we can use it for the winter peak, or we can use it for sectors which are difficult to electrify. The first ideas of this North Sea Wind Power Hub came from TenneT, and they want to make it only electrical. And then they found out that at a certain moment in time, 2030, 2035, 2040, there is too much electricity and not enough demand. So they said, okay, we have to have green energy in our system, but it is not possible to have all the green energy in the form of electrons. So then the concept came of green molecules. So basically what we do via these power to gas installations, which is basically it's an electrolysis installation, we convert the electricity, the green electricity, into green gas, into green molecules. And green molecules are easy to store, are easy to transport, cheaper to store. So we get a better functioning integrated energy system. My expectation of the role of hydrogen in the future energy system, I think it will become quite important. Our best estimate is that the electricity in the Netherlands, the electricity share in the energy system will grow from 20 till 45%. So that you still need some 55% of green molecules. That will be some green gas, but it will also be hydrogen. And I think it will become quite important, hydrogen, so that could be 30–40%, partly generated on the North Sea, but in the longer term future, maybe also the hydrogen comes from the Middle East, where we use solar energy in the Middle East, in the Sahara Desert, to create hydrogen and ship it to the Netherlands, to the ports of Netherlands. But maybe even we ship it not to the ports of the Netherlands, but we ship it to this artificial island in the North Sea and can then distribute from there the hydrogen to all the countries around the North Sea. We think that the role of hydrogen will be very important. It will be a large replacer of the natural gas industry. And what a good thing is that we can use our existing infrastructure, we reuse it for hydrogen services. So we were not sure about it. So last year we used an existing gas pipeline in the south of the Netherlands, and that is now made available for hydrogen uses. So we transport now hydrogen from one industry to another industry. Now, we are also now developing some underground gas storages in old salt caverns, and we're now also investigating, can we store hydrogen in these salt caverns? So basically what we're doing is we're trying to see how we can convert our existing infrastructure into hydrogen utilization. In 2030, We want to create a hydrogen roundabout in the Netherlands, connecting the 5 industrial clusters with each other. And for this roundabout, this hydrogen roundabout, we only need maybe 10% of new infrastructure, and we can reutilize 90% of the existing gas infrastructure. By reutilizing existing infrastructure, we make the future energy system affordable, reliable, and sustainable. The complexity of this concept of the North Sea Wind Power Hub is very big. It has a technical complexity, but it has also a very big regulatory or legal complexity, because are you going to build it in the Netherlands part of the North Sea, or in the Danish part of the North Sea, or in a combination? And if you then ship the electricity towards the coast, does it need to cross borders? And what about liabilities? What about the legal framework? So that needs a lot of cooperation from all the countries around the North Sea. Basically, that needs a lot of cooperation between the EU companies, including the United Kingdom. This is huge, and that makes the project so important, because stepping aside, it would be very difficult that we solve our problem on the Dutch side of the North Sea and the German side on the German part of the North Sea. We have to cooperate and find the solutions that are good for the Netherlands, that are good for Germany, that are good for Europe as a whole, and not sub-optimize on the Dutch or on the Danish sector, I think. One of the interesting parts and interesting complexities of the North Sea Wind Power Hub is that we have to reorganize from a planological point of view the North Sea. Now it's used for shipping lanes, it's used for fishing, it's used for the military industry, it's used for wind farms. So how can we make use of this huge North Sea and allocate it to a North Sea Wind Power Hub, to nature, to shipping? That's going to be a real complexity to be solved by all the North Sea countries. Very complicated. I think the long-term future, it will be electrolyzers, power-to-gas installations with the North Sea Wind Power Hub. But on the short term, we have to start generating a hydrogen economy in the Netherlands. And one of our ideas is that we could do that with the so-called blue hydrogen. And basically that's hydrogen made from natural gas with the CO2 that comes with it to store that under the surface. Maybe a good example of how this integrated energy system works is that you have a lot of sustainable electricity in the north part of Germany, and we have to transport that to the southern part of Germany, where you have the nuclear Ausstieg and the Kohlen Ausstieg. And it's very difficult to lay new infrastructure, electricity infrastructure in Germany. It has to go underground, very complicated, very expensive. So my idea is to have the power-to-gas installations in the northern part of Germany and transport the gas via the Dutch grid, which has ample capacity in the future, to the south of Germany. So we don't need to build new infrastructure, we can use existing infrastructure, and we cross borders. Now, of course, again, there are legal obligations, regulatory complexities, etc. But from an affordability point of view, this is a very good way of integrating electricity and gas infrastructure. So that would be one of the examples that we can gain as a Europe from reutilizing infrastructure, gas and electricity infrastructure, and combining it across Europe. The integration of electricity and molecules in one energy system, the basic idea behind it is that you use those energy carriers where they're good in. Electricity, very easy to use, very easy to generate, renewable generate. Gas, very easy to transport, maybe 10 times cheaper than electricity. And gas storage, molecule storage, is much cheaper, maybe a factor 1,000 cheaper. So we have to combine the advantages of molecules and electrons in one system and make so an affordable and renewable energy system for the future.